As mobile software gets better, the hardware inside tablets or smartphones is more important than ever in comparing mobile performance and increasing battery life. So let's continue Chip Wars, where we cover NVIDIA's Tegra, Qualcomm's Snapdragon, Apple's A-series processors, and Intel's upcoming ultra-low-power mobile chips. This episode is all about Samsung's Exynos 5 processors. It's the processor's architectural design and features that determines computing performance and affects power efficiency. As with all engineering, processor design is all about managing trade-offs. We all want the fastest performing device, but without draining the battery.
Wait a second, why should I care about the parts inside my devices? What difference does it make?
Welcome to the data multiplication revolution. Globally, data is expanding exponentially. 72 hours of video are being uploaded to YouTube every minute. Over 4 billion hours of video are watched each month on YouTube. More than 40 billion photos have been uploaded to Facebook. Mobile data traffic is set to grow by as much as 20 times over the next 5 years. At the heart of this phenomenon is one mega engine responsible for driving this explosion of data. Cats. With Samsung image processor technology, the phenomenon will only escalate. Mobile processors can now support a 13-megapixel image sensor.
Okay, you have my attention now.
Great, so if you're wondering which devices might give you the most bang for your buck by balancing these trade-offs between faster performance and better battery life, keep watching because that's what Chip Wars is all about. Let me do a little catch-up from the last Exynos video. The Exynos 5 Dual was the first dual-core Cortex-A15 introduced in late 2012, hitting up to 1.7 GHz. The 32-bit dual-channel memory bus doubles the performance of the Exynos 4 Quad by clocking in at 800 MHz. This wider memory bus will come in handy to support the Mali T604, ARM's own quad-core GPU design clocked at 533 MHz. The Mali GPU is also built using more flexible unified shader cores. They can compute 3D positions, shapes, and colors, and also support DirectX 11 APIs. And the 32nm fabrication process should boost performance while using 30% less power than the Exynos 4 Dual. But the biggest design win for the Exynos 5 Dual came from this reference device, powering the highest resolution tablet display of 2012. At CES 2013, Samsung announced the Exynos 5 Octa.
We have leveraged the benefits of Exynos 4 Quad and Exynos 5 Dual to create the next breakthrough for our Exynos lineup, the Exynos 5 Octa.
Did you say Octa? As in 8 cores?
Samsung really wants to differentiate the processors in upcoming Galaxy devices. Instead of focusing on the performance jump from the ARM Cortex-A9 to the A15, which is huge by the way, the term Octa is used to signal the power of the new Exynos behind 2013 flagship smartphones and tablets.
So can I use all 8 cores at once? That would be awesome.
Not so fast. It still really functions as a quad-core processor in that only 4 cores are active at any one time. What's unique about this is that it's the first implementation of the Big Little design, ARM's solution to the problem of balancing trade-offs between faster performance and better battery life. The big 1.8 GHz quad-core A15 high-performance cores are great for graphics-rich gaming, HD streaming, or loading complex web pages. But then let's say your screen is idle, waiting for input. Within microseconds, the processor will automatically switch to the little cores to save energy for tasks like texting, email, music, and basic web browsing. For most people, this will make the biggest difference in battery life. When your phone is doing things in the background, like let's say updating a map application with GPS information while you're jogging, or pinging servers for push email, you really don't need to turn on the big high-performance cores. So most people will notice better battery life as the little processors save a ton of power. The Exynos 5 Octa is also built on Samsung's most efficient process at 28 nanometers. But in this implementation, Samsung actually switched GPUs from ARM to PowerVR's tri-core SGX 544 at 533 MHz. It's actually like the SGX 543 in the A5 and A5X, except now it supports DirectX 10 and renders 3D graphics much faster. It's all built on PowerVR's universal scalable shader engine that computes both position and color in the same core unit. If it clocks at the max frequency, the SGX 544 should land right in between the A5X and A6X in terms of graphics performance.
But what does all this data processing do for me? I mean in real life. That's it! I want a new phone, and I want it now.
Well, not so fast. The last flagship Exynos was only available in the Galaxy S4 sold in Europe and Asia, but it was released globally in the larger form factor Galaxy Note 2, and the Exynos 5 Dual, as implemented in the Google Nexus 10 tablet, doesn't have cellular support. So stay tuned as I hope to go over future announcements in Phone Wars and Tablet Wars to see how this evolves.